Hello students, welcome back to Engineers Academy. Kindly subscribe my channel for such more problem solutions. Now I am going to solve this problem 275. In this problem it is said that the weld at O can support a maximum of 2500 Newton of force along each of the N and T direction, right? So the weld at this point O can support the forces in N and T direction, and that maximum force is 2500 Newton, right? So we can say that, let's say that here is a force which is acting in the T direction, let's say this is RT, and let's say that there is one another force which is acting vertically downward, and let's say this is RN, right? So, and it is further said that it supports a maximum of 1400 Newton meter of moment, right? So the moment at point O cannot be greater than this 1400 Newton meter, right? So it is said that determine the allowable range for the direction theta of the 2700 Newton force, right? So this whole system is subjected to this 2700 Newton force, so we are required to find this theta for these given ranges, right? For these given maximum conditions. And it is said that the angle is restricted to this range, right? So the angle is between 0 to 90 degrees. So now if we replace this single force by a force couple system at this point O, so then what will happen is that we will have this same force which will be acting in this same direction at that point, right? At that point O, and it will have that same magnitude, right? So this will be 2700 Newton, right? So then if this is the case, if this is theta, so then this must also be theta, right? So now from this we can say that RT, we can say that RT is the cos component of this 2700 Newton, right? So this is 2700 cos of theta, and similarly that Rn is equal to 2700 sine of theta, right? And the moment produced by this 2700 Newton force at that point O, right? So if we resolve this 2700 Newton force, so again it will be that cos component, right? So this will be 2700 cos of theta, and then it will have one component which will be acting in this direction, so that this one will be the sine component, right? So this one is 2700 sine of theta. So now as we can see that this component is passing through this point O, so it will not produce the moment about point O, so only this sine component is producing the moment about point O, right? So the moment at point O due to this force 2700 Newton force will be 2700 sine of theta into the perpendicular distance, right? So this is the perpendicular distance, which is 0.7 meters, right? So now if we replace this force by a force couple system, so then what we need to do is that we will remove this, we will erase this force, right? So we will erase this force, and we will be left with this force 2700 Newton, and which will have these two components, right? And then as we can see that that force was producing the moment about this point O in the clockwise direction, right? So we can say that this moment is clockwise, right? So let me first find the product of this 2700 and 0.7. So when we solve this, so then this is 1890 sine of theta, right? So now if we apply the conditions, so then we are given that this RT and this Rn, they cannot exceed 2500 Newton, right? So we can say that this must be less than 2500 Newton, and this must be less than 2500 Newton, and this must be less than 1400 Newton meter, right? So this is given, this is 1400 Newton meter, or we can say this must be less than 1400 Newton meter. So now if you want to find this theta, so then this theta will be equal to, we can say that cos of theta must be less than 2500 divided by 2700, and if we take cos inverse, so that will give us theta for this condition, right? So theta must be less than cos inverse 2500 divided by 2700, right? So let me find this. So this comes out to be 22.2 degrees, and similarly we can find theta from this equation as well. So then this will be theta will be less than sine inverse 2500 divided by 2700, and similarly we can find theta from this equation as well. So theta will be less than equal to sine inverse 1400 divided by 1890. So when we solve this, so theta comes out to be 67.80 degrees, and when we solve this equation, so theta comes out to be 47.8 degrees, right? So now from these three theta values, we can say that the theta can be greater than equal to 22.2 degrees, but it should be less than equal to 47.8 degrees, right? If this theta exceeds this value, so then this moment will exceed this 1400 Newton meter, right? So this is the upper boundary, the upper constraint, right? So if we consider this theta, so then already this theta comes in range, right? So this puts the upper constraint on this theta, right? So the theta must be from 22.2 degrees to 47.8 degrees, right? So the theta must not exceed these two values, right? So this is the solution of this particular problem.